Next up, we're going to hear from Werner Vogels. Werner came to Amazon after being a researcher at Cornell University, where he was a master of ultra-scalable systems. And he went on to become one of the chief architects of the Amazon cloud, which he has called, and I think rightly, the world's largest distributed system. And it's much more than that. After 4 years, starting with EC2 and S3, Amazon now offers 20 different services. But today, he told me he wants to talk about the motivations of the customers who come to Amazon Web Services, what they're doing with it, what they want to do with it, and then what their actual behavior is, and how that is steering what he's building in the future. Werner?
Well, thanks for giving me a half hour of your time today. So putting me in a session together with Mark Benioff gives a new idea to, industry heavyweights. Yeah. So there's a clicker here. So, and now actually I'm sure I can beat Mark. So can everybody who is an Amazon.com customer raise their hands? Huh? Can I talk to you later? So Amazon Web Services, infrastructure in the cloud, you know when a technology has reached maturity when this book arrives. Yeah? And actually, I was kind of insulted by this book because I believe that one of the pure concepts around the cloud is simplicity. Yeah? A cloud for dummies should not be necessary. I think one of the opportunities we have is build applications that are really intuitive. And so, but what I really want to talk today, so if you think about Amazon, and I'm not going to talk about all these different services, they have horrible acronyms. So the good thing is that Mark is a sales guy and is really smooth and is able to bring this message to you. And I'm a technologist. So this is actually the boring section of this talk. Yeah, and so, but to avoid that, I'm not going to mention all the acronyms, the EC2 and S3 and things like that. What I want you to remember is that what Amazon delivers is infrastructure as a service. Yeah, and it's all different from what we've heard about this morning, which is Google Apps and all the other enterprise apps around it, which are consumer-facing, Facebook, and Salesforce and others, all consumer-facing applications. And this is completely down in the belly of the beast. Yeah? This is compute, storage, messaging, networking, all of these kind of things, all your nightmares. Yeah? And we have the ability to take those nightmares away from you. And so for that, we've been, it's a business that is really exploding. This is just an indicator of kind of what the growth is in this business. Amazon Simple Storage Service was launched first in early 2006. These are billions of objects that customers are storing actually in Amazon S3. We're now way over 100 billion. And more than the really actual numbers, what is important is actually the curve that you see what this growth is happening. And from my perspective, the way that we're looking at it, we haven't even reached the knee of the hockey stick yet. This is really going to explode. And this is now 4 years into providing the cloud to our customers, and many of our customers really innovating with it. And now we get rewarded for this. Jeff, front page of Business Week's, most innovative companies, also because of the cloud. But when we launched this, Business Week had a completely different title. Yeah? And this is Amazon's whiskey bet. Yeah? And this is also how many of our customers still look at the cloud. Remember, Business Week is no longer in business. So what I want to do is actually first start off with a number of our customers, dive deep on why they actually picked to run their applications on infrastructure as a service. Dive deep on what actually the different things are that they were doing with it. And then, give my motivation why I think cloud is really important. And then, finish off with reviewing a set of other customers. So this is the NASDAQ. So the NASDAQ, the data group of the NASDAQ, maintains all the feeds that are coming from the exchanges. They go in a massive back-end infrastructure. And what they were confronted with was that customers would call them and ask for ad hoc queries against that data set. And they were not set up for that. But they did think that there was a business there. And they did as good enterprise architects are, they developed a new architecture, or developed it, or at least mapped it out, and realized that to be able to support this business, they would have to revamp the complete back-end architecture. Is it $6 to $10 million to be able to do that, a 2-year-long process for an application or for a business that they actually didn't know could be successful or not. And so they did something really simple. They actually split the big fire hose that were coming from the exchanges, and next to dumping it into the traditional architecture, they also dumped it into Amazon S3. Simple text files, small text files per ticker symbol, per 10 minutes, a really embarrassing simple solution. Then they picked a whole set of Flash objects, built an application out of it, allowed customers to run that on their own desktops, and then retrieved this data from Amazon S3. Now, it turns out that this application is really successful. You can go to data.nasdaq.com, download the application, play with it. It really works really well. But for them, it was really important that they made no capital investment to get this application off the ground. Because if it turned out that this was an application that was not going to be successful, they wanted to do so with minimum loss. Yeah, and after actually, that was the real motivation, was no capital investment, but the other motivations like, reduced operational costs, they didn't have to look after the storage systems, they were sick and tired of running their own databases, they didn't want to have another 10 databases to look after, which they would have to keep up 24/7, because that would be the cycle on which their customers would be using. Another example, Razorfish. Some of you may know them as Avenue A. What they do is actually analysis of clickstream data for their customers, finding out what is actually customers doing on your site. They do market segmentation and things like that. Massive computational data. And I think they're a really good example of what we now know as being big data. Where companies know that they're sitting on a huge amount of data, and there is this needle in there, there's this gold to be had in there, you just don't know where. And these data sets are huge. And Razorfish was confronted with the fact that they were acquiring a new customer, and to actually take this customer through the holiday season, they would need another $500,000 of actually hardware investment to just support this customer. And so they also want to do a lot of new innovation in terms of building out new algorithms and things like that, but they don't have any real big infrastructure to do this on. So they move all of this over to Amazon S3, store all the data there, continuously move customer data there, and they use Elastic MapReduce, which is a version of Hadoop that Amazon manages on top of the EC2 infrastructure for them to experiment with. And they can do this experimentation continuously without having to worry about, not yes or no having enough capacity. Again, for them, the driver was scalability, but to be able to be flexible, to figure out, to develop new algorithms as they come, not having to worry about the amount of capacity that you need to drive these algorithms. Bild is a large German publishing house. Just like many of the other media companies, they are trying to figure out new business models. And so one of the areas that they wanted to go into was video citizen journalism, which means that their customers can walk around with cell phones, take videos, upload them to this website, and then create news stories out of that. They went to their internal IT department. They said, oh, that's a really great idea. 9 to 12 months, then we can deliver this to you. It's obvious that in the media world and in the internet age, 9 to 12 months means you're dead in the water. So they moved on to the Amazon platform, launched in 4 weeks after conception. And not necessarily with the whole product, as they would have done maybe 5 years ago. They launched with a smaller product, which you could really get to market really fast, and then start innovating on top of it by looking at how the customers are actually using that particular product. Not knowing upfront how much computation they would need for it, how much storage, and things like that. So time to market was crucial for them. You may have seen this news. Lawson, very large ERP provider, launched their software as a service product. They launched that on top of Amazon EC2. Their main criteria was that they really needed to be able to quickly roll out customers and be able to scale those customers to any size. And actually, Lawson also thought it was, of course, really important if you run customers' critical processes on this, that it's ultra reliable. So for them, the choice was really, what's the most reliable infrastructure that we can find? But they also decided to do a lot of innovation around it. They have a whole new structure in terms of licensing, but they also have something that's called a Lawson test drive, where you can take this environment, quickly spin it up, and customers can load their data on it, and then for 3 months they can just use it for free, figure out whether this is actually a product they want to use. And if it turns out that this is a product they do not want to use, then it's easy for them to take it down and forget about the cost and forget about the data. Netflix is another great example. They came to Amazon because it's obvious that their business model is changing. Yeah, they're really going from a DVD rental company into a digital streaming company. And so for them, that meant tremendous scale that they would have to deal with. And also reliability, because suddenly, this whole infrastructure needs to be super reliable, because that will be the core of your business. So they looked around, for what platform they would build this on. They picked the Amazon Web Services, and probably they had to swallow a little bit then, because on the same platform, Amazon's video on demand runs. Yeah? And here we have a platform where we have two competitors running side by side, both having the same advantages from it. Yeah? So for Netflix, their biggest challenge was, if they would have to build this complete reliable infrastructure themselves with multiple network providers, multiple data centers all over the world, they rather take their expertise and focus on delivering better video service or a better customer experience than actually investing all of that intellectual capital also in the infrastructure. Now, you can see this as, all these enterprises building their businesses on top of the cloud, and then, there is still this myth out there that, by the time it is actually holiday season, all of this will collapse. Yeah? Because when it's holiday season, Amazon, who was just selling off some extra capacity, will take all of that back when they have a better than expected holiday season. Yeah? Of course, that's ridiculous. The idea that all of these large enterprises are moving on to Amazon Web Services, they realize that this is a business for Amazon by itself. Yeah? The reason why Amazon went into this business is because we believe this will be really, really big. Yeah? Probably, and of course nobody has a real crystal ball, but we believe that it will be on the size of our e-commerce operation at this time. Yeah? Or maybe even bigger. But we don't know how the future is going to look like. Amazon.com itself is a very large customer on top of this, but definitely not the largest customer. Yeah? There's many more large customers, just like Amazon, on the same platform. Now, if you look at the sort of different use cases of customers using this, these are sort of, this is one of those fancy Wordle kind of things that indicate what are the kind of common use cases enterprises are using. And there's a few that I actually want to highlight, and we'll get into the more detail later. Disaster recovery is definitely something that is really heating up. Many CIOs hate to write this check once a year, very large check, and not having the ability to actually continuously test whether you can do disaster recovery or not. They want something that actually is in their hands and can test continuously whether your DR is actually working. Yeah? You can obviously see HPC and marketing, we'll get to that later. Collaboration, many folks as sort of first proof of concepts are moving their SharePoint clusters into the cloud, wikis into the cloud, all these kind of environments moving into Amazon EC2 for easy growth and easy shrinking as well. Load testing is another example we'll get to. Now, there's many different ways in defining cloud computing. You've seen a number of this morning. I like to reiterate one that actually Gartner used about 2 years ago. I think Gartner bashing is a very popular sport these days. And actually, I think it's a really good definition. Yeah, it's a style of computing where you have massively scalable IT-related capabilities that are provided as a service across the internet to multiple external customers. And the key points there are massively scalable IT-related capabilities as a service, and across the internet, that can be public and private internet, and by nature it's multi-tenant. However, I do think there are 2 things missing in this definition that are crucial. And that actually, from my point of view, make cloud cloud. Yeah? The one thing that is missing from this definition is that these resources should be available in an on-demand fashion. You need to be able to get access to these resources whenever you want. And if you no longer want to use them, you can be able to just release those resources. And you can also see that as a meta level. Yeah? This needs to be on a purely self-service basis. If you want to use our services, go ahead. If you no longer want to use our services, you should be able to walk away without any upfront commitments or things like that. So both at the detailed level, yeah, getting an access to compute resources and releasing them whenever you want to, but also at the business level. And the other thing that is missing from this definition is that it needs to be a pay-as-you-go model. In my eyes, at the infrastructure level, that's the only model that makes sense. Yeah? You only pay for those resources that you use. And if you don't use them, you should not be paying for them. In that sense, it's as close to the pure utility model as possible. Yeah, so if you look back, early 1900s, many of the companies, this is actually a picture of a brewery in Belgium, where they had their own generator to be able to brew beer. Yeah? You can imagine these two things have nothing to do with each other. These guys needed to have 12 people on staff just to keep the generator going. Yeah? Just the cost of doing business, and that has nothing to do with brewing better beer. So when public utilities came around, they couldn't quickly enough actually dump the generator and switch over to public utilities so that they could actually focus their resources on what they really want was their differentiator, which was their types of beers. And so that's actually the core, I think, of infrastructure as a service and the utility model that goes with it. So when we developed these services, when we built these services first for ourselves internally, but when we started externalizing them, there were a few principles that we built these services with. Yeah? The first one is that they needed to be scalable. And with that, I mean, you need to be able to increase and decrease this in the order of minutes. Yeah? If you want to get access to resources, that shouldn't be an hour-long process. Actually, within Amazon, we had quite a bit of experience with that because I believe we were really good before we had this platform. You could fill in a web form, and capacity would be delivered to you in order of hours. So fill in the form, 2-3 hours, you would have 10 servers fully provisioned for you available. It turned out that that didn't trigger the engineers to actually release capacity when they no longer needed it. You can imagine at the end of the holiday season, during that period, engineers and teams would have additional capacity. So on January 1st, you should expect that a lot of capacity gets freed up. Yeah? And then you would go talk to engineers and they would say, you ask them, why aren't you releasing capacity? Well, just in case. Yeah? And, oh no, we're launching something in March 1st, and we thought it would be easier to hang on to it than to actually release it and ask for it back again. So there's two things that we thought were really important. You need to be able to get access to these resources in order of minutes, yeah? And it needs to be fully automatable. You need to take these engineers out. You need to have just an API in which you can get access to these resources and then build automated systems around it that release these resources when you no longer need them, based on business principles more than on the judgment of an engineer. It needs to be cost effective, which means for us, Amazon, coming out of the retail business, we really understand a large, high volume, low margin business. And we've been building technology for the past 15 years that actually powers that e-commerce operation. And so we really know what it means to drive the cost to the floor. So it needs to be really cheap. And I also want to maintain the same principles as that we have in our e-commerce business, which is if, because of our economies of scale, are capable of getting additional cost savings, we will turn around and lower prices for our customers. And we've done that in the Amazon Web Services business a number of times as well. Yeah, we've, I think, lowered bandwidth pricing 3 times now in the past 4 years. Last November, we actually lowered prices on our compute instances, pure because of our economy of scale, we're able to drive the cost down. And of course, Amazon.com runs on this infrastructure, and we really understand reliability from a mission-critical point of view. we also understand that many of our customers are going to use these services and build their business completely on this. There are quite a few customers that for full 100% run on Amazon Web Services. They have no servers, no data centers anymore. So many business-critical applications will be running on this infrastructure, so it needs to be super reliable because we feel that we're responsible for your livelihood, and that's something we take really, really serious. The same goes for security, and we also feel, because in security, it's not a matter of just being secure. In security, there is no finish line. It's something where you have to continuously innovate in to make sure that you can keep your customers secure. Again, with Amazon.com, we have a long history there, understanding how important security is. And actually, if you look at our investment priorities in the Amazon Web Services, but also at the Amazon.com side, security continues to rank #1 in terms of our investments. So if you look a bit at, often, we can take all of these technical definitions of what cloud is and things like that. I think cloud really gets defined by the benefits that you get from it more than from the technology pieces of it. So important for cloud is that it has to lower cost. You should eliminate capital investment, but also reduce operational cost. And the reducing of operational cost really comes from the fact that you do not pay for those resources that you do not use. So scalability is not only a matter of scaling up, it is as important to be able to scale down. And if you be able to scale down, you should be able to reduce your operational cost as well. So many of our enterprise customers come to us with this lowering cost principle in mind. But often when they get on board and they've been running for a while, they will not cite, although they still like the lowering cost, they often cite increasing agility as a much more important principle of the cloud. The fact that they are no longer constrained in their thinking about resources and that they can really drive time to market, really compress that in a way that they've never been able to do before. Of course, it's important that our customers, if they use this infrastructure as a service, no longer have to think about data centers, not multiple data centers, not how to replicate data across multiple data centers, how to negotiate with multiple network providers such that you're fault tolerant in that manner. All of these kind of things come for free with infrastructure as a service. And also important, and it's also a principle actually that many of our customers cite as really important to them, is that because of the simplicity of these services and the scalability and the easy access to shrinking and growing and multiple data centers and things like that, they're able to build much simpler, scalable services and applications on top of this. Now, of course, remember if we go back to this previous picture about the generator that was decommissioned at the brewery, not everybody was happy with that, particularly the generator vendors. Yeah? They were not happy with the fact that you were no longer buying any generators. So, these days, and this morning we talked a little bit about private cloud. If you think about the benefits from the cloud in terms of reducing cost and improving agility, private cloud doesn't bring you this. It's a bit like the generator vendor, which you have just dumped, telling you, no, wait, you need to start your own utility. Yeah? Because that's where your big benefit is going to come from. The big benefits from the cloud are the fact that you no longer have to hold capital, yet get access to these unconstrained resources that are out there. Now, for some of our customers, really important that there is a transition phase. And you can see this transition phase as internal, but there is a principle that we've used with Amazon, a feature that we've added to Amazon EC2, where you can actually seamlessly extending your data center. So how does this work? So you can take the Amazon cloud, cordon a piece of that cloud off using a sort of a firewall or a walled garden approach, assign your own addressing to that space, and then start populating that with Amazon resources. You connect that back with a VPN to your own data center, and now this piece of the cloud looks as if it is part of your own data center. Any of the Amazon resources that you put in this VPC, this virtual private cloud, cannot communicate to the outside world except through the VPN that's running back to your own data center. This allows you to manage all sorts of dependencies between the apps that you're now running in the cloud and the apps that you're running in your own data center. Also, data flows through your standard policy engines and your firewalls and things like that. So this actually helps you with transitioning into the cloud, but also managing all sorts of requirements that you may have. So important for many of our customers is actually that they're able to do worldwide deployment of their applications. And earlier today, we heard lots of good things about how transparent the cloud is. You know, the cloud is really the cloud. We don't know where all these services are. You don't need to know where these servers sit or where these data centers are. And that's okay at the application level. At the infrastructure level, that is not okay. Yeah, because there's many things that are really important to developers that have to use the infrastructure services that for them we mean to break this transparency. Yeah? One thing is for performance reasons. Yeah? Latency still matters. Where you place your applications over the world, whether you do this in the EU or whether you're West Coast or East Coast US or Asia, latency really matters. Also, you need to be able to sustain many different failure modes. So you need to get access to multiple data centers or multiple availability zones, as we call them, such that you can build fault tolerance applications. But most importantly, these kind of boundaries need to also follow jurisdictions, yeah, such that, for example, the EU has a whole set of different privacy regulations, which means that as an engineer, as a developer using these services, you need to be able to be sure that if you store data in the EU, that data will never leave the EU. And maybe at the application level, you want to make this all transparent to your customers, but those of us who really have to deal with security and certification and compliance know that you have to have fine-grained controls to actually manage this. So Amazon deploys what's called regions. Those regions follow jurisdictions. And by using that principle, you can actually place applications all over the world. So there's an EU region, there's a West Coast, East Coast region, and this is in the first half of this year, so that's almost over, but very soon we'll be launching a Southeast Asia region as well. And it's not just, we talked earlier about pay-as-you-go, but there's actually more models that we're innovating on. So on-demand is one of them. If you want to run 24/7, there's a reserved instances model which can really drive the cost down. And recently we also introduced a spot market, yeah, where you can actually decide what's the price of my computation when I want to run it. And then there's a spot market where you can actually enter these jobs into, and they will be run at the moment that your price will be met. So there's many partners in this. Important for us is, and that's a really important principle, is that there's maximum flexibility for our customers. Yeah? We do not lock you into any operating system, any database, any programming language. Yeah? If you want to run Windows Server 2008 with Mono or with the .NET tools, or you want to run Apache in it, then you should be able to do so. So all of these operating systems of these vendors are all available in the cloud. You can also use many of the open source ones, all their databases, all their middleware, all of it is supported software. And not only actually at the higher level, not only the big tools, but for example, Oracle also allows you with RMAN, the backup tool, to actually pick Amazon S3 as a backup target. Many of your traditional software vendors all run on top of this platform. They've all integrated it into their management tools. There's many more actually that could go on this slide. Same goes for many of the system integrators. All of them have practices around integrating your applications onto the Amazon cloud. So I want to close up with a few other examples. These are some examples of high-performance computing customers that we have, and they're all different. You know, Eli Lilly wanted to have a high-performance compute environment for collaborative drug testing, but for them it was important that this would happen out in the open, meaning that they didn't want to give all these resources, researchers actually access to the Eli Lilly data centers. So they stamp out a sort of collaborative environment in the cloud, completely secure, where all these researchers work together, and then data from that flows back to the Eli Lilly data centers. Pfizer is the other way around. They wanted to have a completely secure environment with a VPN back to their own data centers. And they use the Amazon Virtual Private Cloud to actually do, the 512 node computational engines. One sort of slam dunk area where infrastructure as a service works really well is, of course, in the internet services business. Here's a whole range from them. Facebook been mentioned many times these days. Playfish is one of the top game providers. But actually, if you look at the whole list of Facebook applications, the top 7 in there that are not actually made by Facebook themselves, all run on the Amazon cloud. And all of these, why? Because all of these were businesses that actually were not in business about 2 years ago. To be able to grow, to sustain something like, 75 million customers a month, you actually have to be able to be on a platform that allows you to grow this fast. And also, if you launch any marketing campaign these days, marketing campaign is no longer just a website. It's a website, it's streaming video, it is user-generated content, it's some casual gaming, it's integration into Facebook. All of these things, you need to be prepared for success. So it's a slam dunk to run that in the cloud instead of, scaling those for peak in your own data centers. This one I wanted to introduce because so testing in the cloud is a big deal. We all know that it's very close to April 15. Yeah? Intuit's TurboTax program is, of course, an online version of that. Intuit wanted to make sure that this could actually sustain all the traffic that's going to happen 2 days from now, because just like, delivering homework in school, we are all going to deliver this on April 15, of course. So Soesta, which is a testing company, fired up, 3,000 instances in the Amazon cloud, simulating 300,000 browsers at the same time submitting their tax forms into Intuit. Testing is a big deal in the cloud because now suddenly testers have a whole environment that they didn't have before. And so it's also that these become platforms. Yeah? Remember that it's not just the fact that customers start running their applications in the cloud. At the same time, enterprises start thinking about what is actually the kind of unique IP that I have that it could be reselling in the cloud, where the cloud becomes a marketplace for these services. Yeah, and some enterprises are doing that, because if they're not doing it actually, there's a number of startups and younger businesses that are doing it. So Siemens and Ribbit, for example, Ribbit is a voice over IP package that actually is now owned by British Telecom, but Twilio is actually a younger business that does fully programmable voice and SMS services. Really that simple, you can now build completely voice and SMS-enabled applications, and on a pure pay-as-you-go model. Simple Geo, another example of a company that provides you with location-based services. Now, with all of these higher-level services, it becomes very simple to build a whole range of new applications that weren't possible before. Add to that data that comes from Salesforce, add to that data that comes out of your Google Apps, and you'll have an environment that is much richer than that we had even 2 years ago. Now, where is Amazon heading with this? There's only 2 things that I want to emphasize. Our top priorities in terms of investment in the Amazon Web Services business are continuing focus on operational excellence, because it is absolutely crucial that we continue to focus on availability and reliability. There's nothing more important than that, except for maybe point number 2 on this list, which is security. And of course, there's the online and real-time security, but also certification in terms of SAS 70, and ISO 27001, and a number of the other certifications that are all on the way, and that they're important for our customers. Yeah, so I want to close this off. If you think about as an infrastructure services, infrastructure as a service provider, what do I think are really the important criteria when you pick one? Yeah? Of course, I think security, I want to emphasize that once more, security is exceptionally important. Is the provider that you're going to pick not only providing you with security, but are they innovating in it? Yeah, for example, there's this whole new engine that provides you very fine-grained policy control over who can access which objects. These guys from Germany on that subnet with those identifiers are able to access this queue in a read fashion or between 3 and 4 on a Friday afternoon. Yeah? And it's not that we want customers to actually type in those rules, but many of your enterprises will have very extensive, higher-level policy engines that can map down onto this very rich security infrastructure. Yeah, operational performance will, of course, remain. Yeah, what is the track record of this company? Cost, are they driving costs down? Are they giving you benefits by you actually joining up? Are you getting the benefit of actually the economy of scale? And as I mentioned earlier, I think it is really important for you to be able to determine which operating system, which programming language, which environment you want to run on this infrastructure. Yeah? And as I mentioned earlier, is this provider actually continuing to innovate and making sure that you can provide can get access to a richer ecosystem? Yeah, so with that, I want to leave it. The only thing that you really need is this URL and a credit card. And that's all you need to get started. Although we also do billing, and we also do invoicing, and we do all the other things that enterprises want. Thank you.
Thank you very much, Werner. And now we'll have a short break, I believe in the tents, and also back that way. You'll find we need to reconvene in 15 minutes at 3:30. You'll find that Dave's team, aside from being really good programmers, are terrific pastry chefs. Thanks.